Welcome to Digital and FinTech Analytics channel.
Hi friends, uh, today we will introduce the topic of temporal fracture effect and how is it being implemented. We will be using the grouping transaction into group size function to implement the temporal fracture effect concept. And the temporal fracture effect, this is being denoted by this function because grouping transactions into group size actually does all the maths behind the temporal fracture effect. So let's dive right into it. So I will be explaining the concept of temporal fracture effect by taking into consideration one of the user ID. For one of the user ID, say like user ID equal to 2, how the temporal fracture effect creates the profile, purchasing profile for the user ID 2. So if you see, the user ID 2 has done 15 transactions and the group size is 7. So 15 is not a perfectly divisible number by 7. So the flag is equal to 3. So as we saw above, the grouping transactions into group size takes two parameters as an input. One is like the within decay rate list, which is the output of temporal ripple effect, and the flag values. So within decay rate list is basically for user ID 2, we have created a column within decay rate list whose length is also of 15. So basically for 15 transactions, we have created a embedding vector using the concept of temporal ripple effect. So that will be the input and the flag value, which is basically 3. So let's call this function grouping transactions into group size, and we'll be passing the within decay list corresponding to user ID 2. For that, we write something like this: dfhist.lock dfhist user ID equal to uid. So uid here has been mentioned as 2. So it's for user ID 2. It is subsetting the data and getting the within decay rate list and converting it into values or like list format. Uh, and along with that, we are also sending the flag value corresponding to user ID 2. So so what it does, let's get into the function. So so it takes the within decay rate list that we get from the temporal ripple effect and the flag values, and then it inserts and it does some check. So if flag equal to 1, so flag equal to 1 means like if the number of transactions are exactly divisible by the number of group. So here the number of group is 7 and number of transactions is 15, where like it is not exactly divisible. So we will skip this part. Had it been exactly divisible, then what we have done is basically I will explain it quickly. So say like in case the number of transactions is equal to 14 and group size is equal to 7. So here like 14 divided by 7 is equal to 2, or like 14 modulo 7 is equal to 0. The remainder is 0. So it's like exactly divisible. So in this kind of scenario, what we will do is like, what does like this mean? This mean like we have like 14 transactions and 7 group that we have to make. So if you say like this is group 1, group 2, group 3, 4, 5, 6, and 7. So corresponding to each of the group, so say like these are like the group. So corresponding to each group, there we have to club how many transactions? So corresponding to each group, you have to club 2 transactions, and that will be giving us our final group size. So here there will be 2 transactions. Here there will be 2 transactions, 2, 2, 2, 2, and 2. So 2 transactions means like corresponding to this, if I have to explain, there would be like 2 embedding vector that will be coming from the temporal ripple effect. So these two transactions, say like these two transactions will be of uh, length 2 cross number of products that we have in the database, which is like 11997. So we will add these two to get our final vector, which will be of the length 1 cross 11997. So similarly, this process will be repeated for all the 7 groups, and we will be getting um, 7 different profile. Okay, and then we will be giving some high weightage to high weight values to the final or the most recent fracture, and the least weightage to the earliest transaction. So this is when the so this is what we do when the flag value is equal to 1. That is, the number of transaction is exactly divided by the total number of groups or the group size that we are trying to do. The next condition is, so that's what is happening over here in the flag equal to 1 flag equal to 1 condition. Next it says like if the flag is equal to 2, whereas the number of transactions is lesser than the group. So here we are not doing any kind of grouping because we have just one group, because we can't make 7 different groups because the number of transaction is lesser than the group. So it will be just one group. That's flag equal to 2. The the complicated part is like the flag equal to 3, which I will be explaining, where the number of transactions are not exactly divisible by the number of group. So what we do in that particular case, let's see with the help of this example. So as I was saying earlier, for user ID 2, we have around 15 transactions, and the group size is 7, and 15 is not divisible by 7. So the flag corresponding to that is 3. So when we pass the two parameter, one is the embeddings from the temporal ripple effect or the within decay rate list, and the flag values to grouping transactions into group size function. So what it does is like so it will skip the flag equal to 1 condition, skip the flag equal to 2 condition, and it will directly enter into flag equal to 3 condition. Now what is happening over here? Let's understand with the help of this example. So first it will enter this flag equal to 3 loop, and it will say like flag 3 number of transactions are not divisible by number of group, where the length of transaction is 15 and the group size is 7. So here we see where length of transaction is 15 and group size is 7. After that, it will calculate few of the things, which is first of all it will calculate estimated number of vector in each block. So this is like length of within decay rate list divided by group size. So let's do the maths simultaneously also. So the length of within decay rate list is basically 15, and the group size is 7. So we will be having some 2 point something as the estimated number of vector in each block. So if you see, we are printing it over here. So let's have a look at it. So estimated number of vector in each block is 2.14. So basically it says approximately how much uh, transactions should be present in each of the group if divided equally. So it's 2.14. Then it calculates base number of vector in each block. So what is this? Is basically it says like uh, if you take the whole number of list, so basically whole transactions. So what it does over here is it floors the value that we calculated over here. So 2.14 was what we were getting over here. That is what is being calculated over here. But the floor, what it will do is like it will, instead of taking 2.14 as the face value, it will lower it down to the lower denomination. So here the lower denomination of 2.14 is 2. So it says like base number of vector in each block should be 2. If you see here, we are printing it up. If you see, the base number of vector in each block is 2. Then it's calculates something known as residual. Residual is basically estimated number of vector in each block, which is basically 2.14, minus the base number of vector in each block, which is 2. So 0.14 is the residual, and we are printing it over here. So let's see the residual. Residual is 0.14. Now what it does is like, it says like number of vector has extra vec. So how it is calculating this particular num vec has extra vec is basically it multiplies the residual value into the group size. So basically 0.14 into 7, and it rounds up to the nearest whole number. So if you see 0.14 into 7, when we do, it gives us 0.98, and when we round it up, it is 1. So so basically it says, if you see like num vec has extra vec, the value should be 1. So basically it says in the 7 groups, if you put like 2 transactions in each group, then 14 transactions are being accommodated. And there is one more transaction which is not being accommodated. So we have to do some adjustment to accommodate this extra transaction that is coming into the scene. So pictorially, if you have to see this, then it will look something like this. So say like person A has done around 15 transactions. So we will say like this is the first transaction, second, say like this is the scenario where like person A has like 15 transactions, and each of the transaction is being represented by the help of a vector. So what we are doing over here is we are calculating few of these things, like the estimated number of vector in each block, base number vector in each block. So that basically says like overall we can adjust like 2 transactions in each group or in each fractures. So let's see how it unfolds. Um, so first thing we do is like first few groups. So in the first few group, we get like the group size minus the number of vector that has extra vector. So group size is here 7, and num vec has extra vec, which is coming from here is like 1. So to first few groups are basically first 6 groups is what they're talking about. So if you see like this print statement where first few groups, where each group should have uh, this many elements or this many transactions. So if you see the output of that, so it says, yeah, first few groups is like 6. So first 6 groups, where like each group should have 2 elements. So 12 transactions are completed. Elements and transactions are kind of the same thing. I will be using interchangeably. So in the first 6 groups, we'll be taking like 2 transactions into each of the group. So first 12 transactions are being handled easily. So for that, what we are doing is, uh, yeah, we are total number of elements in the first few groups is like 6 into 2, 12. So total number of elements in the first few groups is like 12, and the within decay rate list has a shape of 15 comma 1997. Let's see like this in the outputs. So total number of elements in the first few groups, because we have like 6 groups and 2 transactions in each groups. So total of 12 transactions have been taken into account for grouping it. And the within decay rate list, this is the output of the ripple effect for the user ID 2. So it says like we have like 15 transactions, and each transaction is of the length 11,997, out of which 12 transactions has been grouped into 6 groups. Okay, so let's see where we left. Yeah, so here what we are doing is like, np.array is basically converting the within decay rate list, which was a list of list, into an array, and it is subsetting. It is basically, if you see like this is known as slicing. This operator is known as slicing in list. So it is taking total number of elements from the first few groups, which is basically 12. So out of the 15 transactions, 12 transactions are being taken into account, and np.array converts it into numpy array, which will be useful for any numpy related calculation. And then what we are doing is like we are creating we are saving it in like all transactions array first few. That all transaction array first few is reshaped into this particular format, where first few groups basically means like first few groups is six groups, first six groups comma minus one comma item number. So what does this minus one does is basically we know like we want six groups, and the length of the item length of each of the groups should be 11,997. That is coming from item number, because we have that number of distinct products in our database. Now what does this minus do? This is very interesting. When you pass minus one as any one of the dimension, then numpy automatically uh, creates this dimension by doing some adjustment. So we had like this all transactions array first few was after this subsetting, we know like it had like 12 transactions, and each transaction was of length 11,997. Now we are saying numpy convert this two-dimensional array 12 by 1997 in this format, where like the first so this is two-dimensional, here we are saying to do a three-dimensional array. So what it will do is like first few groups is basically six, and the length is like 11,997, and this minus one will automatically understand it should be two transactions per group. So six groups, we are saying numpy to convert it into six group and automatically adjust the middle dimension such that the six group accommodates all the 12 transactions. And so like this numpy dot reshape helps in does doing the same thing. If you see this output that has been printed, all transactions array first few one dot shape, then we will be seeing that, yeah, if you see like 6 by 2 by 119,11997, which means now we have successfully converted the 12 transactions from the within decay rate list into six group, where each group has two transactions and the length of each of the transaction is 11,997. So that is being shown in the output also when I am printing. If you see like first group, second group, third group, fourth group, fifth group, and sixth group. So that's what we are printing it over here, like the all transactions array first few one. We are printing all the groups that we are grouping it over here. Okay. For better clarity, I can explain these few lines with the help of the board. Let's go over to the board. So what it says like out of these 15 transactions initially, it is grouping. It is taking only the first 12 transactions. Okay. The first 12 transactions is being taken into account, and what it does to those 12 transaction. Yeah. So when I say like the first 12 transaction is being taken into account, it is being done in this particular uh, slicing. So the using the ripple, using the vector that we're getting from the ripple effect, only the first 12 transactions is being taken into account and is being saved in all transactions array first few. So these 12 transactions are being saved in all transactions array first few. So these 12 transactions are being saved in this particular numpy array. So the shape of this numpy array is now 12 by 11997. Okay. Now what we are doing is like we are calling this, we are using this particular array, all transaction first few that we created, and we are reshaping it. We are reshaping it in a way like this 12 transactions should be converted into six group. So what we are doing over here is like let's do it uh, over here again, like we are calling this same array, all transactions, whatever it is, the same array, and we are using numpy reshape function, and we are passing three different parameter over here. The first one is the number of groups. So the number of groups over here is first few groups. So if you remember the first few groups that we are calculating from this, the from here, where group size is 7 and num vector has extra vec is basically 1. So a total of 6 group is there. So we are saying like convert it into 6 group, and the length of each group, or the length of each transactions in the group, is like basically given by this item number. Item number is 11997, total number of items in the database, and we are passing -1 over here. So what does this -1 do? So what -1 does over here is like it automatically understands that there are 12 transactions earlier, and these 12 transactions needs to be converted into 6 groups. So 6 groups means like each group should have 2 transactions. So it does those numpy adjustment of the numpy adjustment, and it basically understand we want to convert this two-dimensional array into three-dimensional array, where like the outer dimension, this one basically represents number of groups. So in this particular case it's 6 groups, and the second dimensional basically says like how many transactions should be present in each group. So here it automatically understands that there should be 2 transactions in each group. Then only 6 into 12 will give us 6 into 2 will give us 12 transactions in total, that is present over here, and the length of each of the transactions is of 11,997 long. So that's pretty much talks about like how we are doing this reshape. I would highly encourage the viewers to read through the documentation of this reshape, NumPy reshape, to understand, have a better understanding, and play with this number by taking some dummy examples. Okay. Yeah. Having said that, we have already converted the 12 transactions into 6 groups. Now what we are doing is like in this particular uh, case, like what we are doing, like those 6 groups that we created. So I'll try to explain over here. So there is like group 1, group 2, group 3, group 6. So each group has 2 transactions over here. Now we further, and the length of this and the dimension of each of the group is 1 by 2 by 11997. So like we have 6 group, so the final dimension is so when we have 6 group and all the groups are in a same array, so it is 6 by 2 by 11997. But what we want for each of the group to be represented by a single vector. So for that, what we do is like this is known as the dimension 0 of an array. This is known as dimension 1 of an array, and this is known as the dimension 2 of an array. So in this particular case, what we are saying, like sum all the arrays via the x is equal to 1. X is equal to 1 means like via the first dimension. Sum it via the first dimension. So if you sum this vector, this 3D vector via like dimension 1, or x is equal to 1, so it will do element wise addition of all these array and will give us the final single array whose dimension will be 1 by 1 by 11997. Okay. So when we are doing the same when we are doing the same operation on this holistic array, which is basically the six groups. So the six group has the dimension of 6 by 2 by 1, 1, 9, and 7, and we are asking it to submit by x is equal to 1. That's what we were doing over here. So it converts this whole of the six group. Each group has two transactions. Now it sums each of the groups two transactions into one transaction. It does an element wise addition, and the final output is 6 by 1 by 11997. And we also do a normalization by dividing it by number of transactions in each of the group. So which is basically uh, all 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 these intermediate groups are being divided by the number of transactions that were present in each group. So basically two. So we are dividing it. So this is known as normalization. So there is a lot of normalization as very important uh, use in the case of data science and machine learning. But here, since we will be doing some distance based calculations in the next steps. So normalization will help us to bring all the large values within a particular range, and the distance based calculation is being done in an optimized way. So that's why we do the normalization over here. So yeah, so if you see the final shape of all the transactions array first few, which is being saved over here, all transactions array first few to dot shape. So if you see like the final the final length or the final dimension of the vector is like 6 by 11997. So yeah, so as I was saying, like this is being the final, when we are summing it by x is equal to 1. So this 6 by 1 by 1197 is same as 6 by 11997. So yeah, after summing it up via axis 1, one of the x's gets reduced, and the final um, dimension is six groups, and each group is of length 11,997. So all the six group has been taken care of. There is one final group which is like group 7. We wanted like total of 7 groups. So 6 group has been taken care. The final group has to accommodate like these 3 transactions. How is it doing it? Let's see in the next step. So here, first of all, we are calculating estimated number, that is going to be estimated number, which is basically the uh, seal version of this variable. So if you see like estimated number of vector in each block was 2.14, right? Estimated number of vector in each block is 2.14. When we do a seal of that, seal means like there are the two mathematical function. One we saw is known as floor, and floor means like you think it's a we have a room. The room has a floor and the room has a ceiling. So floor means like it will take the lower value. So in this case, the lower value of 2.14 was 2. Here seal means the ceiling of 2.14. The higher value of 2.14 is nearest whole number of 2.14 in the highest form is 3. So estimated number is basically, it says like 3. So if you see, estimated number is 3. Next what we do is like we take the last 3 transactions. So the last 3 transactions was not being accounted into the 6 groups that we created earlier. So we do slicing, where we say like the total number of elements in from the first few groups, which was like 12 earlier, that we calculated from here, total number of elements in the first few groups. If you see in the output also, yeah, so until 12 transactions, we had taken it into 6 group. We had accounted the first 12 transactions into 6 group. So after 12 transactions, whatever transactions are present, so in this case, we have like 13, 14, and 15, those 3 transactions, we are doing a slicing operator by saying like only pick the transactions after the 12 transactions, then colon that does that slicing of this list and takes all those three transactions into this particular variable, all transactions array rest. And if you see like the shape of this all transactions array rest, it should be 3 by 11,997. So let's see the output of this. Yeah, the all transaction array rest is of the length 3, suggesting 3 transactions, and each transaction is of the length 11,997. And finally, we are saying like number of groups left. So total group size was 7, and the first few groups were like 6. So we had only one group left. So we have only one group left, which is saved over here, number of groups left. So here when you are printing number of groups left to be created is 1, in which group in each group we'll have estimated number of transactions. So what does this means? Like number of groups left to be created is 1, and in each group we'll be having 3 transactions. So that's what will be printed over here. Number of groups left to be created is 1, and in each group we'll be having 3 transactions. So basically that means like in one group we'll be having 3 transactions in total. So for that we are doing this reshaping thing. So what we are doing is like we are taking this array transaction, all transactions array rest, and we are reshaping it into one group. Number of groups left is basically one group. The shape of this all transaction array is rest is basically 3 transactions, and each transaction is of length 11,997. When we are reshaping it into one group, it says like convert the 3 transactions into one group which has 3 transactions. This minus 1 will take into account of the 3 transactions, and by item number is like 11,997. So what it does over here, if I have to explain, so these 3 transactions we are earlier having the shape of 3 by 11997, but what we want is like we want to group these 3 transactions into one group. So we do that numpy reshape function, and we convert this one into this three, we convert these 3 transactions into 1 by 3 by 11,997 array. It's a 3-dimensional array where it says like one group which has like 3 transactions, and the length of each transaction is 11,997. And again we are doing the same operation where like we are summing all the 3 transactions by x is equal to 1. So the axis over here, when you say like x is equal to 1, is basically this axis. We are summing it along this axis. So all these 3 transactions is being converted into one transaction, uh, because there is like element wise summation of all these 3 transactions, and that will give us resultant one group, and the final group will be of the length 1 cross 11997. So the 3 transactions have been converted into one group, into one single vector. That is our 7th group. Okay, and definitely we are doing the same kind of normalization where we are dividing. After summing it up, we are again dividing it by the number of transactions, which is basically 3. So this is the normalization step that I was explaining earlier. Okay, so that's what we are doing over here. We are summing it up along x is equal to 1, and then we are normalizing it with the number of transactions. Finally what we have is like we had like 6 transactions coming from this all transactions array first few 2, and we have like 6 groups that is coming from this all transactions array first few 2, and we have one group which is coming from which we just calculated all transactions array rest left 2. So we are concatenating this 6 group and this one group into one group, and we are doing some reshaping on top of that. So when we concatenate these two, so what happens is like we had earlier 6 by 11,997. This is 6 group, and the one group that we calculated earlier is 1 cross 11,997. So when we concatenate these two, we will be getting 7 groups, and each group is of length 11,997. And then we are doing some reshaping on top of this. So what this reshaping does, it says like convert it into this format, into three-dimensional format, so as to explain it in a better way. So that reshaping is like converting this thing to 7 7 cross 1 cross 11,997. So this explicitly means like we have seven groups, and each group is of the length 11,000 1 by 11,997. So each group is represented by this this vector. And finally, we are returning that the final arrays and the shape of the final arrays. So the number of groups that is being created. So for that, we will be running. I will just comment this one out. This has no print function, so it will be easy to run over all the transactions that we have. And so I will run this particular shell. So yeah, so what we do over here again, similar way like we calculated temporal ripple effect, uh, we'll be calculating the temporal fracture effect, and we'll be passing these two parameter within decay rate list that we are getting from the output of temporal ripple effect in the flag values for each of the user to this function grouping transactions into group size, and we will run it. Since we had like two outputs that are being shared, one is like the final arrays after grouping it into 7 groups, and the shape of that array, the final shape, which should be like 7, uh, that is being returned over here. Now if we do a df hist dot add, we see the output of this transactions into group size has been created. So all this list are having the length 7, condensed length 7, and as explained in the function, the calculation has been performed and the final output is written. So that's pretty much on the group transactions into group size. Uh, the next part is like where we'll be giving. So yeah, so in the next part, what we'll see is like once we have created all the 7 groups that I was explaining, uh, this these 7 groups, we have to give some weightage. Once those 7 groups have been created, we have to give some weightage. So how that thing is happening, we'll understand in the next video.
That's a wrap for today's video. If you found this content valuable, make sure to hit that like button and subscribe to the channel so you don't miss out on future insights into data science, AI, machine learning, and analytics. Looking to master data science or drive data-driven success? I offer expert training, mentorship, and consultancy for individuals and organizations. Let's collaborate. Reach out via my contact details in the bio.